Bismillahirrahmanirrahim. Assalamu alaikum. Today is our lecture 3 and we are going to study about the system, some of its type, and we'll also go through some of the examples of types of systems. First of all, uh, look at the system. What is system? Systems actually process the signals to create new signals. For example, this is for example, we have a system, and here the input is x of n, and it's giving us an output y of n. We'll give a signal to the system. The system will work on that signal and will give us our desired signal y of n. The types of systems are the serial or the cascaded system. On passing through multiple systems, getting the desired signal. For example, first of all, it will go to the h1, the first signal, and then second system. Then we'll get our desired output signal. The second one is the parallel system. In this type of systems, there are multiple systems, and a signal have to pass through multiple signals at a time parallelly. In the third case, the feedback system, you can see from the diagram that depending upon the output of first system, it gives us our desired output, our desired signal. Now come to the causal systems. The causal systems uses current or the delayed means past values. For example, these are the examples of causal systems. In these, x of n shows the current value. X of n shows the current value because there is no shift in the first term. In the second term, there is a shift of -1. This means this is the delayed or the past value. In any equation of system, if there is x minus 1 or x minus 2 or x minus 1000 or 10, it will show that this is the delayed value, and this is the equation of causal system. In the first, we have current as well as the delayed or past value, but in the second example we have only the delayed value. These both of these are the causal system equations. In the second, you have non-causal system. The difference between the non-causal and the causal system is simple. This is that this use the delayed or past values, and this use the future values or the advanced values. Here, if there is positive sign, this will show that this is non-causal system. Here the negative sign shows that this is causal system. Come to the one of the most important type of system, which is the linear system. If we want to check that our system is linear or not, we will have to check whether it holds the property of additivity and the homogeneity. For checking the additivity, for example, we have two signals. By adding the inputs of both signal, it will give us the addition of the outputs. For homogeneity, if we have multiplied with the constant term, that multiplied constant term should be there at the output side. And on superposing both the properties, we'll get this expression. If some system's equation is satisfying this expression, this means that will be a linear system, and if not, that will obviously a non-linear system. Now let's check by examples. Here is the example of linear system. We will given with an system with a system equation, and we will have to tell whether it is linear or not. First of all, we have two systems. We will write it in form of two different systems. Then x1 plus x2 is equals to zn. We will say zn is equals to x1 plus x1 of n plus x2 of n, and this expression on passing zn from the given system, we'll get this expression, and we will simply plug in the value of zn is equals to x1 plus x2 into this equation, and we'll get our desired value. Here you can see that it is holding the property of additivity, Now come to the homogeneity. In homogeneity, we have multiplied, for example, we have multiplied with alpha, the scaling factor alpha on the input side. It will, if we get that factor on the output, this means that the system is homogeneous too. This is holding the property of homogeneity, hence this is the linear system. In the same way, here is an example for the nonlinear system. It is not holding the property of additivity or the homogeneity, and it is nonlinear. Here are the some real life examples of linear system, which are the wave propagation, null system. Null systems are those which who always give us zero output. Unity systems which give us 1 at the output always. The electric circuits, convolution, multiplication by constant or signal changings. Here are the examples for the nonlinear systems in the real life. These are the hysteresis, saturation, applying threshold on a linear. If we have a linear system and we apply a threshold on it, then it will become the, for example, we have a system and it is linear and it is going this way, but if we apply some threshold, it will stop here. It will become non-linear. Now come to the time invariant system or the time variant system. Time invariant system are those which are independent of time. The word invariant tells us that which are independent of time. Here we have x of n, the input signal, it will give us y of n, the output signal. In this type of systems, we actually create a shift in the input, and if it gives the same shift on the output, that will be called as the invariant system. Here we have an example. We have applied n minus n naught on the input side and it have given the same result, so it is time invariant system. In real life, the real life examples for the time invariant and variant systems are the electric circuits, fan, projector for the time invariant, and for variant system we have internet or Wi-Fi or cooling system. Here is an example. This is time invariant system because it is we have the input signal, we have the system equation, Zn is equals to x n minus n naught. We have created a shift of n naught in the signal, and it has satisfied the property, so it is time invariant system. Another example, for example, this is the system equation and this is the given signal. Now we have to pass this signal through this system and show our output. On passing the signal through the system, we have to work out like this, and it is too difficult. So another easy way to solve this is, if we get impulse response, we can easily find value. We get impulse response by passing impulse from the system. What is an impulse? Impulse is any spike at 0 anywhere. Okay, by passing an impulse signal, this means that we have replaced the x with the impulse signal. So this shows that we'll get a spike on the value on the 0, we'll get a spike at 1, we'll get a spike at 2 with the magnitude of 3, with the magnitude of 2, and with the magnitude of 1. When there is nothing, it is 1. Okay, so we'll get impulse response as 1, minus 2, and 3. This double line shows that this is at 0. This is the first method, is the sealed shift version of impulse response. In this we are applying the formula of convolution, which is x of n cross h of n. H of n is this, impulse response is h of n, and x of n means x of 0, 1 and 2. We are multiplying with x of 0, 1 and 2 and getting this on adding the above responses, we'll get 1, minus 1, 2, 1, 3. By using the third method, which is flip and slide method, we have this signal, and on using this method we again get 1, minus 1, 2, 1 and 3. Now come to the convolution, correlation. Convolution and correlation are the most important things in this, are the most important concepts in this subject or in this course of DSP. In convolution, we only we flip and slide. We flip and then slide our signal, but in correlation we only slide our signal. The applications of correlation are the measuring similarity of signal. What actually we do in correlation, we find the similarity between two signals. um, mm, the second application of correlation is the pattern recognition, then signal detection, extract. We can also extract radar signals using autocorrelation. We can find weather forecast and water traffic monitoring. So that's all for today. Thank you so much.